Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 11, Tax, Commissions, Fees, and Other Real-World Percent Problems. Okay, so it starts off with a classwork opening exercise. Tax, commission, gratuity, and fees. How are each of the following percent applications different, and how are they the same? Solve each problem, and then compare your solution process for each problem. We are going to use the equation of some quantity equals some percent times a whole. Okay, so Silvio earns 10%. So I'm going to just substitute in underneath 10% is 0.1 or 0.10. Silvio earns 10% for each car sale he makes while working at a used car dealership. If he sells a used car for $2,000, what is his commission? The $2,000 is the whole. So I'm going to multiply 0.1 times 2,000 to get my quantity. And when I do that, I get my quantity to be, and remember a decimal just moves the decimal one place. So 2,000 times 0.1 is 200. And therefore, on a $2,000 sale, he makes $200 in commission. Number 2, or part B. Two's family stayed at a hotel for 10 nights on their vacation. The hotel charges 10% room tax per night. How much did they pay in room taxes if the room cost $200 per night? Okay, so again, quantity equals percent times the whole. We're trying to find a quantity here. The percent is 10. That goes here, and that's 0.1. So I'm going to take 10% and multiply it by the whole, or what they paid for a room. How much did they pay in room taxes? What's the quantity? If the room costs $200 per night and the tax is 10%. So my quantity is going to equal 10% of $200. So my quantity is going to equal, remember, moving the decimal one place to the left will yield $20. That's how much it costs per night for this hotel room. The family stayed at the hotel for 10 nights. So then I take my nights times my taxes per day, my quantity, and that is going to equal my total taxes. So the number of nights is 10. And the quantity I paid per night was 20, and that will be my total. And 10 times 20 is 200. So the total taxes that the family paid for 10 days in a hotel was $200. Part C says Eric bought a new computer and printer online. He had to pay 10% in shipping fees. The item totaled $2,000. How much did the shipping cost? So we're taking up some quantity equals some percent times the whole. The quantity here is what we're trying to find. What did he pay in shipping costs? That's our Q. 10% shipping fees is our percent. 10% is 0.1. I'm going to take 1.1 and multiply by what he paid for the item, which was $2,000. So the quantity, which is the shipping cost, is 10% of 2,000, which is $200 in shipping. Part D, Selena had her wedding rehearsal dinner at a restaurant. The restaurant's policy is that gratuity is included in the bill for large parties. Her father said the food and service were exceptional, so he wanted to leave an extra 10% tip for the bill on top of the total amount of the bill. If the dinner bill totaled $2,000, how much money did her father leave as the extra tip? So that is our quantity, the extra tip. And that equals some percent times the whole cost of the meal. So we're trying to find the quantity, the extra tip, and it was 10%, which is 0.1, times the whole, which was $2,000 for the dinner. So the quantity equals 0.1 times 2,000, which is $200, on top of the tip that was already included in the dinner. Okay, now I'm going to go back to the top. And it says, how are each of the following percent applications different and how are they the same? Solve and then compare your solutions. So $200 was A, B was $200, C was $200, D was $200. So the answer to this is, for each problem I had to find 10% of a total, which was always $2,000. Even though each problem was different, one was a commission, one was a tax, one was a fee, and one was a gratuity, I arrived at the answer in the same manner. By taking 10% of 2,000 means 1/10 of 2,000, which is $200. All right, now these are exercises. Now it's your turn to test your skills. Pause the video, see if you can do these, and then come back and check the solutions. Okay, so here we go. It says show all work. A calculator may be used for calculations. The school board has approved the addition of a new sports team at your school. The district ordered 30 team uniforms and received a bill for $2,992.50. The total included a 5% discount. A, the school needs to place another order for 2 more uniforms. The company said the discount will not apply because the discount only applies to orders of $1,000 or more. How much will the 2 uniforms cost? Okay, so I need the formula, and I'm going to write some quantity equals some percent times the whole. The quantity in this case we know. We don't know the whole cost. We know the discount price. So that is $2,992.50. Equals some percent of the whole. Well, if we got a 5% discount and 100% is a whole, and we discount at 5%, then we are paying 95%. So my percent is 95% of the whole. In order to find the total cost, I divide both sides by 0.95. And as it said, we may use a calculator. So I take 2,992.5 divided by 0.95, and I got 3,150. So that is my W. That's the whole cost of 30 team uniforms. Okay, so if 30 uniforms, so I'll say 30U is this total here. That's my W. 30 uniforms equals $3,150. Then to find out how much one uniform is, I divide both sides by 30. These 30s cancel, and one uniform will equal, these zeros cancel. 3 goes into 3 once, 3 will not go into 1. 3 goes into 15 5 times. One uniform will cost $105 before this 5% discount. We want to buy, how much will the 2 uniforms cost? So in order to find the price of 2 uniforms, I need to multiply both sides by 2. So I get 2 uniforms equals, and 105 times 2 is $210. So the 2 uniforms are $210. Part B says the school district does not have to pay 8% sales tax on the $2,992.50 purchase. Okay, school districts are tax exempt. Estimate the amount of sales tax the district saved on this purchase and explain how you arrived at your estimate. So I will still use that formula, quantity equals percent times whole. And in this case, we want to know, well, this is a little bit deceiving in this case. We know that the whole in this case is our whole price we paid. And the quantity would be the whole price plus tax, if you think of it that way. So our quantity is going to be 8%, which is 0.08, times what the cost of the uniforms was, which is $2,992.50. So I'm going to multiply 0.08 times $2,992.50 to get the cost, our Q, cost with tax included. So if I get my calculator out, $2,992.50 times 0.08 is $239.40. That is how much the district saved in taxes since they don't have to pay tax. Part C says, a student who loses a uniform must pay a fee equal to 75% of the school cost of a uniform. For a uniform that costs the school $105, will the student owe more or less than $75 for the lost uniform? And it says, explain how to use mental math to determine the answer. Well, mental math in this case, since it says to use mental math, it's not asking for a formula to find an exact value. So 75% means $75 would be 75% of $100, if that makes sense. $75 is 75% of $100. Okay, so it says, will the student owe more or less than $75? Well, the uniform is $105. So if $75 is 75% of 100, then it would have to be more than $75 because we have $105. Because we're going to take another 75% of $5, which would put it over 100. So 75, the student will owe more than $75. Okay, because $75 is 75% of, I should say that, let me write that. $75 is 75% of $100. So therefore it'll be more because we have $105. Okay, that was just mental math on that one. Okay, part D says, write an equation to represent the proportional relationship. Write an equation. All right, so I'm going to write an equal sign. Write an equation to represent the proportional relationship between the school's cost of a uniform and the amount a student must pay for a lost uniform. Use U to represent the uniform cost and S to represent the amount a student must pay for a lost uniform. And up above here it says, a student who loses a uniform must pay a fee equal to 75% of the school's cost of the uniform. So S represents the amount the student must pay. So the amount the student must pay is going to be our quantity, and that is going to equal some percent times the whole. We're using the same equation as before. But in this case, we're not going to say quantity equals some percent times a whole. They told us to use S and U. So S, use U to represent uniform cost, and S to represent the amount the student must pay. And the student must pay 75% of the cost of the uniform, so that would be S equals 0.75 of a uniform U. So there's our equation, S equals 0.75 U. What is the constant of proportionality? Well, the constant of proportionality is our leading coefficient that we're multiplying our uniform variable by. So the constant of proportionality is 75%. 2 says, a taxpayer claims the new sports team caused his school tax to increase by 2%. Write an equation to show the relationship between the school taxes before and after the 2% increase. Use B to represent the dollar amount of school tax before the increase, and T to represent the dollar amount of the school tax after the 2% increase. Okay, so that's what we're trying to find is the T. So the T is going to be what the school tax rate was before times this 2% increase. That will give us the dollar amount after the 2% increase. So we're going to increase the tax amount before by 2%. Well, to increase a value, you always think of something as being 100%, a whole. So remember our equation. Some quantity equals a percent times a whole. A whole is 100%, and that is our B. So if we're going to add 2% to 100%, then that would be 102%. And to represent that as a decimal, you move the decimal 2 places to the left, so that would be 1.02. So that is our coefficient here, 1.02b. That is our constant of proportionality, as it said in the last question. So there is our equation. The taxes after a 2% increase of our original would be 1.02b will equal t. Now it says to use this equation to complete the table below. List at least 5 pairs of values. Well, let's use 0. So if b was 0, 1.02 times 0 is 0. So if the taxes were $0 before a 2% increase, 2% of nothing is nothing. All right. So then I take 1,000. So all I'm doing is substituting in now. So I would say t equals 1.02 times 1,000. And what that does is moves the decimal 3 places to the right, 1, 2, 3, and that would be $1,020. And since 2,000 is twice as much as 1,000, I can just double this and say $2,040. Okay, now they gave me a t, and I have to find b. That's okay, and that's why equations are so handy, and that's why I always stress write an equation or write a formula, substitute the givens, and solve. So if I have 1.02 t, or b, I'm sorry, then I'm just going to substitute in my b. So t equals 1.02b, and here's my t. So I put it over here. 3,060 equals 1.02b. And I'm trying to find b. So I divide, because it's the inverse of multiplication, and I divide both sides by 1.02. And this will cancel this and leave me with my b. So I go to my calculator, and I'm going to take 3,060 and divide it by 1.02, and that will give me 3,000. Okay? And then I'm going to do the same for the 6,120, and then I'm seeing a pattern here. So this is going 0, 1,000, 2,000, 3,000, and this is increasing by 1,020 every time, 20, 40, 30, 60, but then it would only be 40, 80, 6, or 5,000 something. But what I'm seeing here is 3,060 times 2 is 6,120. So they're doubling t, so we must double b. So this should be 6,000. But let's check that with our formula over here. So now I'm going to just erase this and redo the next one. And I was given 6,120 equals 1.02b. Divide both sides by 1.02. Those will cancel, and I will get b equals. And if I go to my calculator and put in 6,120 and divide it by 1.02, then I get 6,000. Part C says, on graph paper, graph the relationship modeled by the equation. Part A, be sure to label the axis and scale. Okay, so here is a graph. I'm only going to be in the first quadrant because we can't have negative taxes. The government does not give us money. That's not how taxes work, so there's no reason to go to the negative side, so we're working in quadrant 1. I want to label my graph, and this is the effects of a 2% school tax increase. Okay, a little messy there. Always label your graph. Okay, the effects of a 2% school tax increase. So over on this side, this is new tax in dollars, and down here is the original tax in dollars. So the origin obviously is 0, and this I'm going to put down here in thousands. That way I don't have to write 1,000 every time. So this is 1,000, 2,000, 3,000, 4,000. You get the idea? Rather than writing all those zeros and trying to squeeze them in here, if you say original tax dollars in thousands, then the reader knows that these are in thousands. And I'm going to do the same here. New tax dollars in thousands. And this will be 1,000, 2,000, and so on. And I'm only going up to 7 here because, as you can see, 6 and 6 are the highest, so 7 will be enough on both. Okay, so now I'm going to graph. So we have the point 0, 0. That is our origin. We have the point 1,000, and 1,020 would be just above 1,000. And then we have 2,000, 2,040, which would be right about here. Okay, 3,000, 3,060. And then 6,000, 6,120, which would probably be about here. So then if I get this would be like you using a ruler, and I draw a segment through my points, then our graph should be pretty close to the points we put. And there is the graph of our points. Okay, they're off a little bit, but you get the idea. This is a constant rate of 2%, so our constant of proportionality is linear, and there is the graph. Okay, now it says, is the relationship proportional? Explain how you know. And you would say yes, because, and I've already said it, the graph is a straight line. And goes through the point 0, 0, or the origin. Part E says, what is the constant of proportionality? What does it mean in the context of the situation? Okay, so the constant of proportionality is how much it increases at a constant rate. And the rate was 1.02%. It was increasing by 2% or 102% each time. So I would say the constant of proportionality is 1.02. It means that after the 2% tax increase, $1.02 will be paid for every dollar of tax paid before the increase. F says, if a taxpayer's school tax rose from $4,000 to $4,020, was there a 20% increase? Justify using your answer using your graph, table, or equation. Okay, so if I use my graph, I want to see if 4,000 to 4,020 was a 2% increase. Let's use the equation. What was our equation? And it's up here. T equals 1.02b. So I'd write T equals 1.02b. So the tax rose from 4,000 to 4,020. Was that a 2% increase? So what I would put is 4,000 is my B, and 4,020 is my T. Tax after and tax before. So I'd write 4,020 here. equals 1.02 times my B, which is 4,000. Okay, so 4,020 equals, I want to check to see if this is true. So then I do the calculation, and I multiply 1.02 times 4,000. Let's just do that over here. And I got 4,080. 4,080 is not equal to 4,020. So was there a 2% increase? The answer is no, there was not. Justify your answer using an equation, which is what I did. 4,020 does not equal 4,080. Number 3 says, the Sports Booster Club sold candles as a fundraiser to support the new team. The club earns a commission on its candle sales, which means it receives a certain percentage of the total dollar amount sold. Okay, so there's our hint right here. Commission is a percentage of the total. So if I use an equation, some quantity equals some percent times the whole. That's what we're going to do again. The club gets to keep 30% of the money. 30% is 0.30. I'm going to put that in right here. There's my 30%. 30% goes there. If the club gets to keep 30% of the money from the candle sales, what would the club's total sales have to be? What would be the total W in order to make at least $500? That is our quantity we're trying to make. So this is our setup. The quantity we have is $500. 30% was given, and we want to know the total, which is the whole. In order to solve this, I multiply both sides, or divide both sides by 0.30. And these cancel, and that will give me my whole. So if I go to my calculator and take 500 and divide it by 0.3, I get $1,666.67. Rounding to the nearest penny. So since that was a round, let's change our equals to an approximation. So the total sales would have to be approximately $1,666.67 to make $500 in commissions. Okay, number 4 says, Christian's mom works at the concession stand during sporting events. She told him they buy candy bars for 75 cents each, and for 75 cents each, and mark them up 40% to sell at the concession stand. What is the amount of the markup? So some quantity equals some percent times the whole. Okay, so the markup is 40%, which is 0.40 or simply 0.4. We're trying to find out what value. Okay, the whole price they pay in this case is the 75 cents. The quantity we're trying to find is our marked up value. And so I'm just going to leave that Q. That's what we're trying to find. So it's Q equals 0.4, and the candy bars are 75 cents, so I'm going to put 0.75. Okay, now this is just going to find the markup. If we want to know the total, remember 100% of something is the whole, which is the 75 cents. And if I'm going to mark it up 40%, then I'm going to be paying 140%. Okay, so I want this 0.04. I could have done it this way, but that would be 2 steps. So I'm just going to change this, and it's 1.40. 1.40 is a markup of 40%. Okay, So it's 100% plus the 40% times the 75 cents that they paid for the candy bars. Okay. So what will it be with a 40% markup? And so therefore I'm going to use my calculator and do 1.4, which is 140%, times the 75 cents they paid for the candy bars, and they're going to sell them for $1.05. So the candy bar costs $1.05 at the concession stand. So we didn't answer the question yet. What is the amount of the markup? How much does the concession stand charge for each candy bar? Well, we answered that already. They charge $1.05. Okay, what is the markup? Well, the markup equals what they charge minus what they paid. So the markup equals the $1.05 minus the 75 cents that they paid. So the markup equals $1.05 minus 75, which is 30 cents. Okay, the markup is $0.30. Okay, now it says, with your group, brainstorm solutions to the problems below. Prepare a poster that shows your solutions and math work. A calculator may be used for calculations. For the next school year, the new soccer team will need to come up with $600. Suppose the team earns $500 from the fundraiser at the start of the current school year, and the money is placed for 1 calendar year in a savings account earning 5% simple interest annually. How much money will the team still need to raise to meet the next year's expenses? So I'm still going to go back to that quantity equals percent times whole. Okay, but in this case we have more going on than that. We're talking about interest. And how do we determine interest? Well, we have a principal amount, what we start with, and then we multiply it by some interest rate, R, and then we multiply that by time. So interest equals principal times rate times time. And that's what we're going to use in this problem. Okay, so we want to find out how much interest we're going to earn on that money. So my interest earned is going to equal my principal of $500 times the interest rate of 5%, which is 0.05, and time is simple interest annually. How much money will the team still need to raise meeting next year's expenses? So the money's placed in for 1 calendar year, so that time is 1. All right, so the time in this case is irrelevant because that's our multiplicative identity. So our interest that we're going to earn is going to be 500 times 0.05. That's easy to calculate. It's 5 times 5 is 25 with 2 zeros, but these 2 decimal places move the decimal 2 places to the right. So it's $2, 500 times 0.05 is, there's another decimal place there. So let's not do it that way. I don't want to confuse you with the decimal places. Okay, so let's just do this. 500 times 0.05 equals 25. Okay, so 0.05 is, okay, I see what I'm doing now. 0.05 is 5%. This is not 5% interest. That would have been back in the 80s, maybe 5% interest. It's a 0.5% interest. So a 0.5% is 0.005. So that would be $2.50. Plugging that into my calculator. 500 times 0.005 equals $2.50. Okay, so when I saw $25, I'm like, there's no way you'd make that on $500. Okay, so it's $2.50. Okay, so did we answer the question? How much money will the team still need to raise? Well, they raised $500. They put the money in an account that earned $2.50 in interest. And so when I add that up, I get $502.50. Okay, I want to subtract that from 600. So total money needed equals $600. The money we have is $502.50 after the interest. So if I subtract those, so I don't want to write T equals here. If I take that $600 that we want, okay, that's what we need, and I made $2.50 interest on the 500 I had, so that's 502.50. I need to subtract those amounts to get what I need. I need $97.50. Okay, part B. Part B says, Jeff is a member of the new sports team. His dad owns a bakery. To help raise money for the team, Jeff's dad agrees to provide the team with cookies to sell at the concession stand for next year's opening game. The team must pay back the bakery 25 cents for each cookie it sells. The concession stand usually sells about 60 to 80 baked goods per game. Use your answer from part A, $97.50, to determine a percent markup for the cookies the team plans to sell next year's opening game. Justify your answer. Okay, so we have a markup and we have a rate. So we want to know some quantity equals some percent times a whole. Same equation over and over and over. So I'm going to let W equal the original price. Okay, and I'm going to let Q, in this case, equal the markup. All right, so we need to determine how much we're going to charge per cookie. And if we go with the lower amount, we don't ever want to underestimate. So if I am assuming that we're going to sell 80 cookies at a game, but we only sell 60, we're going to come up short. So let's use 60 with hopes that we sell more, but anticipating at least selling 60 cookies. So if I take $97.50 and divide it by, I'll do that right here, and I'll take $97.50, and if I divide that by 60 cookies, then what do I get? So if I take the calculator and take the $97.50 that we need to make and divide that by 60, that's going to be $1.63 per cookie. Okay, so I'm just going to write that, $1.63 per cookie if we sell 60. Okay, we have to pay back the bakery 25 cents, right? So it says here, the team must pay the bakery back 25 cents for each cookie it sells. So if we need to profit 163 and we have to give the bakery 25 cents back, then we add those two values. We will get $1.88. So that'd be $1.88 per cookie. But we want to err on the side of caution. So let's add 12 cents to that and make it an even $2. And that way we don't have to deal with change as well. So let's sell the cookies for $2. So that's how we determine that. Okay. So the markup, if we have to pay $2, sell the cookie for $2 and we paid 25 cents for the cookie, then the markup is the $2 minus what we have to pay back Jeff's dad, which is $1.75. Okay, so if we sell the cookies for $2, give Jeff's dad 25 cents for the cookies, we're profiting $1.75, and that is our markup. So that Q equal markup, that is our Q. So I'm going to put 1.75 in here for Q. And instead of using a percent symbol, I'm going to use R. So I'm going to let R equal the percent, or the, how about the markup rate? Okay, that's the rate at which we're going to mark it up. And the original price was the 25 cents we have to give back to Dad, Jeff's dad. Okay? All right, so now we need to know what our percent markup is. We know that we're going to profit $1.75 per cookie, and the original price was 25 cents. So how much was our markup profit? So if I divide both sides now by 0.25, then these cancel, and I find our rate of markup, and there are 4 quarters in a dollar, and then 3 more, so that's 7. Okay, remember that 100% equals 1.0. So 7 is 700%. So then I would say the markup is 700%. That is a staggering markup. Okay, now part C says, suppose the team ends up selling 78 cookies at next year's opening game. Find the percent error in the number of cookies that you estimated would be sold if in your solution to part B. Percent error equals the absolute value of A minus X over X times 100%, where X is the exact value and A is the approximate value. So we estimated 60 cookies would be sold. So first of all, I'm going to assign my values. We're going to let A equal 60, because if you remember, if I go back here, we're going to estimate the 60 cookies sold. That's how we found these values. 9750 divided by 60. So we estimated 60 cookies to be sold. Suppose the team ended up selling 78 cookies. That is the exact value, X. So X, in this case, is 78. So our percent error is the absolute value of A minus X over the absolute value of X times 100%. So 60 minus 78 is negative 18 over the absolute value of 78, which is 78, times 100%. The absolute value of negative 18 is 18 over 78 times 100%. Okay, I can reduce that. It'll go in evenly too. So that would be, so if I reduced 18 over 78, this is one way we can do this without a calculator. Half of 18 is 9, half of 78 is 39. Okay, but that didn't help much because 39, well, 3 will go in both of those. So 3 goes into 9 3 times, and 3 goes into 39 13 times. So we're down to 3 over 13, but that's still tough to work with. So I'm just going to take my calculator and take 18 divided by 78 and hit enter. And it's 0.2307. So I'm just going to say approximately. So that equals approximately, and then why did I write equals? I don't know. I just said I was going to write approximately. Approximately 23%. Okay, so 0.23 times 100% moves the decimal 2 places to the right, and it's 23%. So there was about a 23% error So I'm going to write that. 23% error in our estimate for the number of cookies sold. Okay, that is the end of lesson 11. Review the lesson summary and go do your problem set.